Hi, we're going to take a look at section 1.5 now, and this is going to be addition of real numbers, also called addition of sign numbers, because now we're going to be dealing with positive and negatives and adding those up. Now we're going to have two cases that we're going to be looking at, and the first case is going to be adding numbers with the same sign. We'll come back and fill these in just a minute. Let's take a look at a few examples first. In each of these examples, we're going to add. So the first example says I have a -6 plus a -2. Notice that the two numbers have the same sign. A couple of ways of thinking about this. One way of thinking about it is, let's say you're on a football team and you're headed down the field this way. Now, when you have a -6, what that means is you made a play, but in that play, you took a hit 6 yards back. Now, this says on my next play, I'm still trying to go forward, but I took another hit backwards 2 yards. So now I've gone back. I have not made any kind of a net gain. It's definitely gone in reverse. So that indicates I'm heading back in this direction. How far back? Well, I've gone a total of 8 yards back. Another way to think about it is to say, let's say, for instance, I'm digging a well. Here's ground zero. And when I dig that well, I dig 6 feet down. That's right here. And then once I've dug that 6 feet down, I'm going to dig further down 2 more feet. I've gone a total underground, that's why the negative, and underground 8 total feet. So there's a couple of ways of thinking about it. Excuse me. But I don't want to have to think of a football field every time. I don't want to have to think about digging a well every single time. I'd rather just have a rule that would help me to remember what's going to happen whenever I have numbers that have the same sign. Notice that in order to get this 8, all I have to do is take the 6 and the 2, completely ignoring the signs, just put those two numbers together. 6 plus 2 will give me an 8. So in other words, I'm going to add the digits. Now, for this sign that's right here, the fact that it's negative, notice that both of these signs are negative, and so therefore I'm just simply going to keep the sign. I like it when things are the same. I don't know about you, but I don't like it when things change. I prefer for things to be the same. So when the signs are the same, I'm going to keep the sign. I like things the same. All right, so let's take a look at a couple more examples of this using simply the rule instead of thinking of football fields or thinking of digging wells. This time I have a -4.7, and I'm going to add a -5.6. Notice the use of the parentheses in these. The use of the parentheses is to distinguish that we are having an addition problem right here, but we are adding a negative number. The parentheses separates out the fact that this is a negative and draws attention to that. So that's why it's there. So now what we said was, since the signs are the same, I've got a negative, I've got a negative right here and another negative right here. Signs are the same. That means I'm going to add the digits. So a 4.7 and a 5.6 is going to be a 10.3. And since the signs are the same, I'm simply going to keep that sign. If they're both negative, I'm going to keep it negative. I like it when things are the same. And one more example. Actually, I'm going to move this example. Well, no, let's go ahead and keep it here. I have a -2/3 and a -5/7 that I'm adding together. Oh no, more fractions. We thought we were done with fractions. We finished up section 1-2. Oh no, fractions will never go away. We got to get really good at it. But we know how to do this. Because remember, when the signs are the same, I'm going to add the digits. Now, the problem is that these digits are fractions, but you know how to add fractions. We've been through this. Remember, the gain symbol here is for multiplication, and X means multiplication. That's when you cancel in the diagonals on multiplication. It's addition and subtraction where you get the common denominator. So I need a common denominator for these two, and as I look at these, I've got a 3 and I've got a 7. Common denominator is going to be a 21. So I'm going to turn them each into a 21. That means I'm going to take this 3 and multiply it by 7. And remember, I got to do that on the numerator as well. 2 times 7 will give me a 14. Now remember, this is a negative, so I'm going to keep it as a negative. Now I'm going to take this 7, I'm going to multiply it by 3 to get a 21. Do the same thing on the numerator. 3 times 5 will give me a 15. And remember, again, it's also negative, so I'm going to keep it as negative. Now that I've got common denominators, I'm going to add up those digits. Remember, that was the next thing. Add the digits. So ignoring the sign. So I'm going to say a 14 over 21 plus a 15 over 21. Well, 14 and 15 will give me a 29. And remember, with fractions, that's the superhero of fractions is that denominator. Don't mess with it. And plus, you worked really hard to get the common denominator. Let's keep it then. So combine them up. I'm going to get a 29 over 21. Now I'm going to keep the sign because I like it that they're the same. So I'm going to keep it. And it's going to be a negative 29 over 21. Do you turn it into a mixed number? When do you turn it into a mixed number? Right. You turn it into a mixed number when you start with a mixed number. We didn't. We started with these improper fractions. Well, they're not improper. We started with basic fractions. So you don't need to turn it into a mixed number unless you started with a mixed number. But remember, My Math Lab's a picky program, so be sure that you follow whatever My Math Lab tells you to do. So that's what happens when you add numbers that have the same sign. Now let's take a look at what happens whenever you have numbers that have different signs with. Adding numbers with different signs. And just like on the last one, we'll fill these in here in just a minute. I want to take a look at some examples first. And we're still going to add each. There we go. Okay. So this time I have a negative 9 plus 3. Now, if we go with the idea of the football field, and remember that means I'm heading this direction. This first play right here took a hit 9 yards back. But on the next play, I gained some yardage and I went 3 yards forward. What is my net gain or loss? Well, remember, if I kicked 9 yards back and went 3 yards forward, it's a net loss. And to indicate that, that's going to be a negative. And it's a net loss of 6. So that's if you liken it to a football field. If you liken it to digging a well, then here's ground zero. I just dug down 9 feet, but then I climbed up and filled it in with dirt 3 feet. So I'm still underneath, I'm still below ground zero, so that's the indication for the negative. But because I dug up 3 feet, I'm only down 6 feet below zero. So that's another way to look at it. Now the cool thing with different signs is a third way to look at it here is to say, well, because those signs are going to be different, then what happens is these 3 cancel out 3 of these. So when these 3 cancel out 3 of these, I'm left with 6 of these. So 6 of the negatives is what I'm left with. So if you think of it that way, then what happens is the rule says, okay, if these 3 are canceling out 3 of these, then that means I'm going to take the 3 away from the 9. So I'm going to take the smaller number, smaller digit, take the smaller digit from the larger digit. Ignoring the signs, completely ignoring the fact that this one's negative and this one's positive. Just look at the digits themselves. When I take the 3 from the 9, sure enough, I get a 6. And then notice that this 6 is negative. Well, as I compare the two digits, 9 is bigger and its sign is negative. So what's going to happen is I'm going to take the sign of the larger digit. And that's how you add two numbers that have different signs. Pretty easy process when you think of it that way. So let's try a couple more examples. And this time I've got a 1.2 plus a negative 6.5. And notice yet again that the signs are different here. When the signs are different, then remember what that indicates is that these cancel out 1.2 of these. So in other words, I'm going to have some of these left over. That indicates that my answer is going to be negative. When I take the 1.2 and cancel out some of these, the number that's left is going to be 5.3. And that goes along with the rules that says take the smaller digit from the larger digit, totally ignoring the signs. So if I ignore the signs that these are positive and negative, and I take this 1.2 away from the 6.5, sure enough, that leaves me with a 5.3. And then I take the sign of the larger digit. Well, the 6.5 is bigger, its sign is negative, so that's how we come up with a negative 5.3 for our answer. And one more. I have a negative 3/8 plus a 6/11. There's those fractions again. Like I said, not going to get rid of them. They exist, so we got to get good at it. So signs are different. That means I'm going to take the smaller from the larger. But with fractions, it's hard to tell which one is larger and which one's smaller. How do you do that? You're right. You're going to compare them with common denominators because that's going to allow us to get equivalent fractions. The LCD, the least common denominator for an 8 and 11, is going to be an 88. So I'm going to convert them both into 88. That means I'm going to take this 8 and multiply it by 11, take this 3 and multiply it by 11, and I get a 33 on that numerator. And remember, it is a negative. Now, over here, that means I'm going to take the 11 and multiply it by 8, multiply this numerator by 8, and I get a 48. And I'm going to add the 2. So now that I've got them as common denominators, remember the denominator is the type of slice. So I have 33 of these 88s, and I've got 48 of these 88s. So now what I'm going to do, since the signs are different, is I'm going to take the smaller from the larger, completely ignoring the sign. Matter of fact, I probably ought to write that up here in addition to that, because I keep saying it over and over again. Take the smaller digit from the larger digit, ignoring the signs. Let's add that in there, because that is very important. You have to ignore the signs whenever you're doing that. So when I ignore the signs, the 33 from the 48 will give me 15. And remember, that's the superhero of fractions, that denominator. You don't want to mess with that, so I'm going to keep it as it is. I've worked awfully hard to get it, so I'm going to keep it. And then remember, I'm going to take the sign of the larger digit. 48 was larger, it's positive, so my answer is going to be positive. Now, remember, you always need to simplify fractions. Is there a number that will go into both 15 and 88? You're right. No, there is nothing that will go into 15 and 88. So you know you're done with that. Now, these are all pretty simple, so we're going to expand on this a bit, and we're going to move on to algebraic expressions, because we know that we can take what we've got here and build on that, because we had no variables in there, and you know that a lot of times you have to deal with variables. So let's turn these into algebraic expressions, and basically you're going to have the same rules, but you're just going to work those coefficients. Like we discussed before, back in section 1.4, we said whenever you combine up like terms, you retain what's making them alike, that's the variable, and you work the coefficients. So you're going to do the very same thing here, it's just now you're going to be dealing with signed numbers. Otherwise, same old rules. So I've got 3 examples. I have 107x plus a negative 40x. Now remember, with like terms, and these are alike because they both have an x to the first, x to the first, so they are alike. When they're alike, I can combine them, and all I'm going to do is work the coefficients. I'm going to retain what's making them alike, that's the x, and just deal with the coefficients. So now what I'm going to do is I'm going to take a look at this 107 and this negative 40, and I'm going to combine them up. Signs are different. Remember, when signs are different, we said that what I do is take the smaller digit from the larger digit. So I'm going to take, and I'm totally ignoring the signs. So I'm going to take the 40 from the 107, and that's a difference of 67. And then we said what we're going to do is we're going to take the sign of the larger digit. The larger digit here is 107. It's positive, so my answer is going to remain positive, and you don't have to show the plus. All right, 2 more examples. 3m plus negative 15n minus 11n plus 6m. Again, like terms have the same variables. So as I look at this, I see, okay, I have an m here and I have another m here. Well, that's pretty easy because that one says I have 3 m's in the pile. I'm adding 6 more m's in the pile. I have a total of 9 m's in that pile sitting in front of me. Now, as I look at the rest of it, I go, wait a minute, here's an n, here's an n. Notice that these signs are the same. I've got a negative here, and I've got a negative here. When the signs are the same, remember, all we have to do is add up those digits and keep the sign. Those are easy. So, I'm going to add up the digits at 15 and 11, completely ignoring the sign. 15 and 11 is going to be a 26. And I'm going to keep the sign. Both of them are negative. But remember, I'm combining up like terms, so I have to keep the n in there. Now, are these like terms? No, you're right, because this one has an m and that one has an n, so that's as good as that one's going to get. All right, one last example, and then we're going to take a look at a real-world example so you can see why we're even bothering with this stuff. Now remember, whenever you simplify expressions, algebraic expressions, we discussed before in section 1.4 that they are simplified whenever all the parentheses are removed and all the like terms are combined. I see a parentheses there, so I've got to remove it. And we discussed in that section that to remove the parentheses, that means I'm going to distribute the 7 through. By multiplication, when things sit beside each other, it indicates multiplication. So 7 times 3y, 7 times 3 is 21, so I have 21 of those y's sitting in front of me. And 7 times 5 will be a 35. And don't forget this guy in the back here. So I removed all those parentheses. Now I just need to combine up my like terms. Here's a y, here's a y. So I'm going to combine them up. I'm going to work the coefficients, and I'm going to retain what's making them alike. That's the y. When I work the coefficients, notice this one's positive, this one's negative. The signs are different. When the signs are different, recall that all we have to do is take the smaller digit from the larger digit and then take the sign of the larger. So when I take the smaller 21 from the larger 25, the difference is 4. The sign of the larger, well, 25 is bigger, so I'm going to take its sign, which is negative. And don't forget this little 35 guy in the back, because he's there and he's very important, so we don't want to lose him. So we're going to carry him over. And remember, the sign in front's the sign that goes. That's the name tag, guys. It's very important that you keep that name tag on there. I work with the preschool kids in my church, and those little guys, you got to put a name tag on them so that we know who they are. And we don't put the name tag on the back because I need to associate the name with the face so that I know who they are. And if they take their name tag off, I have no clue who they are. So it's very important the name tag goes on the front. So this is a negative 25. This is a positive 21. This is a positive 35. The name tag is the sign in front. And the sign in front is the sign that goes. So I'm going to carry this positive over as a positive 35. Those are not like terms. This one has a y, that one doesn't have a y. So there's nothing I can do with it. And that one's as good as that one's going to get. All right, our real world example, and then we are done. Real world example, and then we're done. So during a drought, the level of Cottonwood Creek, here in West Virginia, that would be Cottonwood Creek. Anyways, so during a drought, the level of Cottonwood Creek dropped 18 inches after a storm it rose 2 inches. Later, the level dropped 4 inches. And we want to know what is the net change. So we want to use algebraic symbols to express this, and this is the point of your sign numbers. So in the first part, during the drought, we said it dropped 18 inches. How do you express that mathematically? Sure, a drop would be negative, so negative 18. Then we said, okay, now we get some rain, and it rose 2 inches. Well, if it rises, how do you express that mathematically? Sure, plus 2. Then we said after that, well, we have another drought, and this time it's going to drop 4 inches. How do you express that mathematically? Yeah, negative 4. Now, we need to figure out the net change, so we're going to combine all these up. Now, remember, we said that addition is commutative and associative. You can reorder and regroup for the addition, but we do have a subtraction in here. So we're going to have to go right down the line. So we'll take care of the first 2 first, and a negative 18 plus 2, those signs are different. Remember, when signs are different, you take the smaller digit from the larger digit, ignoring the signs. So if I ignore the signs, 2 smaller, 2 from 18 is 16, and I'm going to take the sign of the larger. The larger is 18, its sign is negative. So that's the result of that combination. But then don't forget this minus 4 that's in the back. I got to carry it down. Now when I take that negative 16 minus 4, the signs are the same. When signs are the same, we combine the digits and we keep the sign. So my net change is going to be negative 20. Now, folks, this is a real-world situation. When you have a real-world situation or a word problem, you always need to include your units. That's negative 20 what? Is it negative raindrops? Is it negative 20 people? What is it? Negative 20 inches. So we need to be sure to include our units in there. Okay, clean that up a little bit, make it look better. There we go. So that's the use of sign numbers, and that's everything that you need to know out of section 1.5. You are good to go with everything you can possibly see there. When we get into section 1.6, we'll take a look at how to subtract sign numbers, and then in 1.7, we'll look at how to multiply and divide sign numbers. But for now, we're just going to deal with addition. Get into my math lab and go lift those weights. Have a good day.